Okay, we're on.
Are you sure you were not on your face?
Yeah, here's the screen. Okay, so we started talking about constructors, right?
Yes.
Let's go. Where's some of the code that we went through for constructors? Okay, so we went through this one, right? So class boat, we have 3 constructors here. You can call it with either 2 parameters, 1 parameter, or 0 parameters. And you create a boat, you can provide that stuff right over here. Okay?
Remind me basically what is constructor?
Constructor builds the object for you before you can use it. And you can provide parameters for what to do with it.
Okay.
So here we do boat and we pass in length and it'll set it. Right?
Is it zero behind you?
Oh, wow. That's awesome.
Yeah.
Wow, there's a couple of them.
Yeah.
Wow, that's gorgeous. How did you see that?
I had too much fun. Like I've seen stuff and I don't know.
Okay. Okay, so let's go through the text. Do you want to go through this code again? Do you remember this code?
What?
We have a boat, and then anytime you name a method, it's actually not a method, but it looks like a method. It's named the same thing as the class.
Yeah.
And you don't make, for example, I don't do this, right? If I do that, that would not be a constructor.
Yeah.
By constructor, you don't declare anything for return value.
Okay.
That makes it a constructor. Okay? And then over here, you just pass it and it creates it. Okay? So there's the heap and there's the stack. 2 years of memory. Okay? Instance variables go inside. On time?
Is it stuck?
No.
What?
Local variables go in the stack. Instance variables are part of the object.
Yeah.
So they go in the heap.
Yeah.
Okay? Local variables are in the methods and then you go in the stack. Okay, we did this already, so you have like do stuff over here, pops this on top, over here, and then keeps on going back. But every time you call a method, it goes on top of the stack. When it's done, it goes back to you. Okay? Okay, so constructor does look and feel a lot like a method, but it's not a method. Okay, it's got the code that runs when you say new. In other words, the code that runs when you instantiate an object.
Mm-hmm.
The only way to invoke a constructor is with the keyword new. That's how you call it, right? When I do over here, new boat, that is calling the constructor. Okay? If you don't write a constructor, the compiler writes one for you. That's why you never wrote one until now, and your code still works.
What? This was what?
This is why your code has been working until now, even though you did not write a constructor. Because if you don't write one, the compiler writes one for you.
Good.
Mm-hmm. But all it looks like is nothing. It'll look like this. It'll look like this.
Yeah, so it's put the threshold all the time.
It'll just go like this. That's what it'll look like. In other words, well, not that. Whoops, that's wrong. It will look like the boat, like this. It does nothing. Okay? If you don't provide one at all. Okay? Constructors must have the same name as the class. That's the rule. Okay, so what's important about constructor is it runs before the object can be signed to a reference. So before this winds up in boat 1, it already runs the constructor. Mm-hmm. So whatever is inside here gets run, and then it drops into boat 1.
Yeah, okay.
So that's important. So before boat 1 can do anything, he's got everything in place. Okay.
Why it just doesn't?
Switch it. Okay, you're allowed to make a method that has the same name as a class, but just in general, don't do it. It just makes things confusing.
You're allowed.
You're allowed to. For example, I can go like this and make a method called void boat, and it won't be a constructor, It'd be a method, but just don't do it because it's confusing. It's supposed to be reserved for constructors. Okay. Okay. So in general, if possible, you should provide a no argument constructor. In other words, like this. If possible, say you have constructors, make one that has defaults, right? But sometimes it's not possible. I'll give you an example. Say there is a color object. There is in Java. For example, blue, red, green, all this stuff. You can get an object of color and then use it somewhere. When you make a color object, in the constructor, when you call it, you better provide a color. Otherwise, what does it even mean? How do you have a color without any color?
Yeah.
So sometimes you do not want to provide you don't want to provide one that has no argument. You want to force who's ever using the boat to provide some information. In other words, if I were to take away this one, then they would never be able to call this. They can only call it with length or with ease.
If you take what?
If I take this one away.
Oh. Okay, gotcha.
Right? In other words, these are called no argument. There's no argument in there. A no argument constructor. Have one if it makes sense in your code to have some default values. But for example, say you're creating a new person, right? Usually when a code makes a new person, you want to at least give it a name or something, right? So you want to force at least them to give a name. So you don't want to have a no argument constructor. Okay? So let's look at this example over here. These are overloaded constructors like we have in our example. These are all fine. This is an int, passes an int. This passes nothing. This passes a boolean. This passes int. Now look at these last two.
Okay.
They actually are different. Even though they're passing the same information, since the order of the arguments are different, it's allowed.
Yeah, it's allowed. But they're not going to the same thing. You have to make sure that when you pass it, also the other side is going to be the same order.
When you call it, you're saying?
Yeah.
Yeah. Yeah. Okay, constructors can be public. Don't worry about these protected things, but they can be any type of setting you want to put to it, whether it's public or private. You could. We're going to look later on. What does it mean to have a private constructor? Why would you want to have a private constructor? Remember, private means no one can call it.
Yeah.
Right? For example, if I go like this and make this private, all these private, no one can run this code.
Mm-hmm.
So then how would someone use the class?
Yes.
Okay, we'll discuss later on what example is there for. Okay, so what happens if you're a superclass and you have a constructor? Right?
Okay.
So if you're a subclass and you have a constructor, in order for you to be built, your parent has to be built first. You can't exist before your parent. So anytime there's a constructor, it actually calls the parent constructor first, then yours. So look at this example over here. There's a class called animal.
Mm-hmm.
All it does, right over here, is
Make it animal.
doesn't make an animal. This is a constructor. The constructor prints out making an animal.
Oh, okay.
Right?
Okay.
Hippo extends an animal. It prints out making a hippo. This all it does. There's nothing else in here.
Yeah, this is constructor.
Right?
Yeah.
So these are both constructors.
Yeah.
Okay, so in this test hippo, we are creating a hippo, right? So what do you think will run first? I'm creating a hippo. Will this run first or will this run first?
The first one.
Which one?
Make an animal.
Right.
Oh. Yeah?
Yeah. So even though I go to a new hippo calls this, and you think that this gets runs, in truth, before this gets run, it calls the animal, and then goes back to here.
Why?
Because the animal must exist before the hippo exists.
Okay. So this is Java doing the by
Itself.
This is if you call equal.
Huh?
When you make a new object, even when you make a new equal, not the new animal, you know what I mean? Like it's going to the equal.
Which one?
You know
Yeah, 100%, yeah. Yeah. because the animal has to exist before this exists.
Okay.
And that is used by super. Java adds a call to super. Super means call
Okay.
the superclass. You don't have to enter this, but Java actually enters this in right before system.
Oh.
That's what Java does for you. Okay, so super actually calls whatever the superclass is. Okay, now sometimes you'll have to actually add that code, because what happens if the superclass constructor takes arguments? Right, you actually have to put in there super and put the argument in there. Okay?
Yes.
Okay, there's a thing with this, or we're going to ignore this for now, because we're not going to really use this until later on. But there's a way, later on when we get to the example, there's this, and we're not going to, let's ignore that for now. Okay. Okay, so how long does an object live for?
But you're not using that. There's nothing to reference them, no?
Yeah, there we go.
What? Did they go?
Mm-hmm.
Ah, yeah.
Okay?
Yes.
If the reference is considered alive,
Yes.
then the object is alive.
It's not.
Then it's dead.
Yeah.
Okay?
Mm.
So let's look at an example over here. First, one more thing. So we mentioned this before. We'll go over it again. See, here's a quick method that has S,
Mhm.
right?
Look.
S can only be used in here.
Yes.
Its scope is in here. That's the word scope. You cannot use it outside of this.
Yeah.
Okay. Okay. So here's three examples of how an object will be eligible to be put in the garbage. Over here. So we have a method called go, and it creates a new object called life.
Okay.
Once it gets to the end, boom, garbage. Because there's no more Z pointing to it anymore, because Z is gone.
Okay.
Yeah?
Like,
Right? Z is a local variable. Remember, Z is gone once the method ends.
yeah, but if you're gonna call after this method, you're gonna create another method to call to the Z. You can.
You can't, because Z is only visible inside here. Remember, local variables are not, you can't see them outside the method.
Okay.
Here's another way. You have life to this, and then you make Z point to a new life.
Mm-hmm.
So this other one over here, that has no more reference anymore. So the first one is gone.
When you're doing Z equal new life. Yeah, I know this one. I know.
And then here's again, make Z to equal null, and therefore no one's pointing to it again.
It's no. Yeah. Okay.
So here are three ways that an object will be gone. Okay. Now, remember, if you have a null, you have 0, you make it equal to null. You cannot then call anything on Z. You cannot do Z bark. If you do, you'll get this, a null pointer exception.
Because, yeah, you're right.
Okay. So that's the gist of.
This is only 9. All this what we learn right now is 9.
Yeah.
It's nothing.
It's nothing. There is an idea of this, but it's not. We're not going to be. I'll wait until we really use real code and then discuss this. Let's go through this right now. Why not?
Oh, we're done. So, whatever we want.
We can do it very quickly. Well, I'll do an example. Watch this. You ready? Say I have some code. Let's go back to over here. Say I have some complicated thing that I don't know, create a car. So it's got to get the engines and everything up. And there's a lot of different ways to call it, but there's some core things that always has to be done. So you don't want to make 5 different constructors that do similar things.
Yeah.
Right? So watch this. Say we have, I'll make a new one. Ready? Check this out. Let's see how I can do this easily. Okay, here, we'll do this example. Ready? Check this out. the best way to do this. Make this a normal example. Okay, we're gonna add something over here called, private. There's a boat, and obviously this is not gonna be real because it won't be a string in real case. It'll be the engine for the boat. Okay. Now, imagine this is a real engine, not just a string. Okay, so you want to set it up. Say setting up the engine is very complicated. Okay. So we could put this. We could put this, say, over here. Look, and we'll pass in a string called P engine, and say it sets the engine that. But imagine the code does a lot more. Okay, engine equals P. Whoops. What did this do? Let's see. What's going on? Where's the wrong button? Okay, so we have a one, we could pass the engine thing and it sets up the engine, right? And then say it does some really, I'm putting comments, do some,
Crazy stuff.
yeah, oops, I cannot see my keyboard. Do some really complicated code, right? Okay, so we don't want to put this complicated code inside all of these. We want these to when they're to set this up.
What?
We don't want to put. If imagine this code is 100 lines long of complicated engine code. We don't want to take this and then put in each of the constructors that every time a person creates a boat, it makes the engine for them, but duplicating the code in all of these. You want these to call this one.
Okay.
Yes? Let me know when you cop that.
You want the both so you're not gonna need to put in each of them?
I don't want to. Then I'm making the same code in each of them.
Yeah.
Right? So I want these to call it. What I can do is this as follows. Ready? I can do this, and I can do provide a default name. Actually, let's. I'll pass in the engine name over here. Ready? String engine brand, whatever. Okay? And then over here, we just go like this. This, and put in the engine brand. So what is this do? This means call this method means call object I'm on the constructor that has this string as a parameter.
Where it's going from, the engine brand, where you bringing it from?
You're getting it from over here.
Yeah, and where you call it? To who?
Huh?
This engine brand, what is taking? I don't know.
It's a string.
Yes.
And it passes in, like a name. I don't know, say like a Honda engine that we put on the boat.
Okay.
And this will then call the engine, set up the engine, and when it's done, finish off setting the length and the name. I could do the same thing for this one now. Right? And then it'll also set the engine before it gets going. Right? Let me know when you got that.
I'm okay, but how does it know that it calls from where it brings the engine brand? Where you bring this method?
We're gonna pass it in here. I mean, what method? It's not a method. It's just the name of a brand. It's a string.
Okay, so what are you trying to do? You didn't tell me you want to copy all of the engine to every. Yeah, I got you.
Over here we'll do, you know, say a Jeep engine, right? And then if you don't provide any of them, then the boat one will provide a default. The default will be, I don't know, what's the default engine? It'll be a Ford. Okay?
Okay, well, in the public boats during the engine, what is it? No, what is this method? What is this method doing?
This is not a method.
This constructor.
Yeah.
What is it doing?
We're setting the engine, which is the instance variable,
Okay.
to equal Ford, Honda, whatever it is that comes in, and then do some really complicated code. We're not actually gonna have real code. Imagine we have to actually create the engine and attach engine to the car, etc. So what we did over here, imagine this is 1,000 lines of code, a really complicated engine code that has to be built before you get your boat into your hands to use.
Yes.
So we can put it all in here and then let all the other constructors just call this one.
Oh, where you call this? What?
This is calling the constructor that has only a string in it, and that's
right. This is not calling to the class that you have.
What is the class?
Boat.
That's right. And what boat constructor starts only with a string?
Engine.
That's it.
But you put engine brand.
Engine brand is just the name of this parameter.
Okay.
That's the string you're passing into it.
Okay, and
Like over here, I'm passing Ford. It's just a string.
But how you create the engine there?
Over here.
Yeah, I got it, but I don't know how they connect to each other. From where?
This is like the same thing as writing boat.
Yes.
That's all it's doing.
Oh, so when you write this, it's called to the constructor.
Yeah.
Oh, now I got it.
Okay. The reason why you do this and you don't do boat is a very simple reason. Because boat means a new class, make a new object.
Yeah.
We're not making a new object. We have this object. But on this object itself, the keyword is on this object itself, or this boat, do it.
Okay, I got it. And now
Okay? When you see this in anywhere in Java, it means this object. So over here, this object would mean
this constructor.
right. Imagine it says this boat. Imagine just like that. Tell me when you get it. If you got it, let me know.
Yeah, I got it.
You got it? So let's see if this works. Gotta just pay for this. I bought it on the other. I mean, I have it bought on my other laptop. Okay, so let's run it now. Okay, it runs fine. Okay. So it's actually I didn't put out a print. Let me put a print out right now. Get
You
engine.
can do get engine, you need to do get a set.
Yeah, so I didn't do one yet, so let's make one right now. Okay.
What about set?
Oops. You're right. We should have a set, but why is it not? Did I spell it wrong? Engine. What did I do wrong? Oh, always do that. Okay. I'll do it. I'll set it another time. Then I'll just use a get. Okay, so let's run it. Okay, so as you see, The engine for the first one was a Honda, next was a Ford, and the last one was a Jeep.
Yeah.
Okay? So that's what this is. That's all it does. So that's how constructors work. They build the object before it lands in this bucket, and this, you call this, it just means call boat. In other words, call this constructor, but you can't write boat because it thinks you're making a new object. It's this same object you're working on, just call this one. And it'll call it. So all these call the complicated this one, and then they go back to their stuff. Okay? That's it, man.
Yeah.
Done with chapter 9.
Now chapter 10, and now we're on the half of the book, no? 18 chapter, bro?
Can't hear you?